Let's talk about Umwelt. Umwelt is a German word meaning how an organism perceives and interprets the world around them. Beginning with the lamprey, one of our oldest vertebrate ancestors, what's really specific about the lamprey and other water-based vertebrates is they have a lateral line system that runs through the length of the entire body, where currents come in and using a bunch of hair cells surrounded by cupula, they can detect currents, the currents around them, and if there are any other organisms moving the currents around them. In addition to this, they have a very basic olfactory system for detecting chemoreceptors, as well as taste buds on the gills. Their optic system is very basic, as they have a cover around their eyeball. So it's still light sensitive, but it's not an eyeball in the way that we think it is. So the way that these guys would interpret the world would be mostly by currents just around them, and by wiggling their body back and forth and detecting the currents and possibly pheromones in the water around them. They detect their prey and any possible predators coming to get them. Cartilaginous, bony, and ray-finned fish also rely heavily on the lateral line system discussed already. However, cartilaginous fish have a couple of tricks up their sleeve. Both cartilaginous and the other types of fish are choanates, which means that they have internal external nares in their olfactory system that allow them to detect chemoreceptors in the water. Cartilaginous fish have very advanced chemoreceptors, allowing them to detect blood in very large amounts of water and from very far away. They also have electromagnetic receptors that allow them to detect fish that might be underneath the sand, because all organisms give off electromagnetic radiation. Fish also have a system in their inner ear that allows them to tell what direction they're facing and whether they're aligned correctly, upwards, downwards, or to the sides. This is called the vestibular system. They also have a gustatory system and an optic system, however not in the ways that we think. They rely heavily on their other senses, their olfactory, and cartilaginous rely heavily on the electromagnetic. So a good way to think of these guys is by smelling, mostly. You're in the water and you have water-specific chemoreceptors, and you're going around and you're detecting currents, and you're smelling possible prey, and you're looking, in some fish, you're looking for predators that are coming to get you, and you're looking at rocks and places to hide that don't give off chemoreceptors. So in discussing amphibians, turtles, and snakes, it becomes a little more relatable to what we perceive as amphibians specifically have trichromatic vision for whatever reason, which allows them to see in 3 colors, much like we can. Snakes can see IR, infrared spectrum as well, which is basically heat, which allows them to detect mice, here's a little mouse, as much as 30 centimeters away from their face just by heat radiation. Here's a little mouse. Also, what's very interesting about amphibians is, since they are, water and land-based, their tactile system is a little bit different. They have to account for humidity a lot, and if they dry out, it's a problem. So they have receptors in their skin for that and for breathing, because they have to keep their skin wet so that oxygen and carbon dioxide can pass through. Amphibians, also, since they are partially aquatic, have retained this lateral line system, at least some have, so that they can detect currents in the water. They all have auditory systems, which allows them to hear things. They have a vestibular system, which allows them to orient themselves, as well as a gustatory system, however. I don't know how that works. Birds are very diverse, so it's hard to get specific into what sort of Umwelts they have or how they would perceive the world. But if we're talking about falciforms or strigiforms, they have very, very strong long-distance vision, but very, very bad up-close vision. So they can see across a football field very clearly. They have trouble seeing within a few centimeters of their face. And so their tactile system is a little bit different. They have very strong tactile receptors on their talons and their beak, which allows them to sense the world up close to them really well. In addition to this, they have salt receptors, or salt outputs, on their nose that allow them to send out all of the salt that they build up, since they are technically reptiles. Yes. And finally we get to mammals, which is also a very diverse series with very different ways of perceiving the world from animal to animal. Starting with the mammals that return to the water, the dolphins and the whales and such, their olfactory system has actually moved to become a blowhole, allowing them to breathe above the water and take in different stuff, as well as their auditory system has been specialized for echolocation. So they use really high-pitched sounds, and then they use the returning of the sounds to detect where they are. This is also seen in some nocturnal animals, some nocturnal mammals, like the bats, specifically the bats, mostly. However, with other nocturnal animals, they have an optic system with a very bright tapetum lucidum on the back of their eye. That's the tapetum lucidum. Here's the cornea. There's an iris, which allows the light to come in and bounce back, and then bounce back again, allowing the animals a second chance at detecting the light. This is a dog. Doesn't look like a dog, it looks like a rabbit, but it's a dog. Dogs and most animals, most mammals, have dichromatic vision. So they're red-green colorblind, because there was no reason for them to need more than 2 cone receptors. However, especially the dog, they have different ways of perceiving the world. They focus a lot on sound and olfactory input. Our smell receptors, each smell receptor only codes for one type of smell. Dogs have many more than humans, and this allows them to gain directionality and detect a lot more in their environment, including vomeronasal inputs. And auditory, they can hear much better. They have a much wider range of sound. I don't know why. It might be due to a larger cochlea and lagina. That's why humans can hear so many different pitches. I don't know why dogs can, but that's how they can. And their eyesight is not so good, so their smell and their auditory system make up for it. Finally, humans and the great apes. We have re-evolved trichromatic vision, which was very important for seeing how ripe the fruits were in the forests where we evolved from great apes into humans. In addition to this, we have a very specific gustatory system for telling the difference between high-calorie foods, which were sweet, and potentially dangerous foods, which were very bitter. Our auditory system, as far as auditory systems go, is pretty good. It's better than fish, but not as good as dogs. You know, we have twice curled cochlea that allows for a long area of sensory, a long area of vibratory input, as well as we evolved 3 jaw bones, the stapes, the malleus, and the incus, from ancient fish into ear bones, as much of the mammals have. Yeah, and that's basically it. So we perceive the world in our way, but different animals perceive it in different ways due to whichever of their systems are the most, or work the best for their environment. You know, dogs will sense with smell, and dolphins will sense with echolocation. Nocturnal animals will see more rods than in cones, and so it's very specific to each animal. Thank you.